Today, nuclear force. So nuclear force is somewhat related with the binding force. See, binding force formula, that is EBN, means binding energy per unit nucleon, means EB by A, right? So that is our EBN, EB by A. See, every atom, every elements have different binding energy. Binding energy means the particle, means is, for example, proton is bound with the other proton. So how one proton is bound with the other protons, that is called binding energy. Now binding energy, we have maximum binding energy is of ion, right? So ion have maximum binding energy, and that energy binding per nucleon, that will be 8.46 mega electron volt. Okay, now between 30 to 120, between this we have element binding energy which is of constant. It constant means with respect to nucleon number, right? So between 30 to 120, this atomic number, between this atomic number elements, we have approximately constant value of binding energy per nucleons, right? If we are having 240, which is very heavy mass, so this is atomic mass 30 and 120, right? So between this atomic mass elements, we are having approximately constant value of binding energy per nucleon. And now we are having, if we have 240 atomic mass of one element, so if by nuclear fission, if we are having two elements which is of 120, so binding energy of these two elements is maximum than the binding energy of 240. So initial binding energy is less than the, after we are getting fragments of elements, that binding energy will be more, right? Now we have to talk about nuclear force. So nuclear force, why? It comes from binding energy, right? Force comes from energy. So behind this nuclear force we are having binding energy. Now nuclear force, see, we have different characteristic of this nuclear force. This force, so nuclear force is stronger than Coulombian force, and it is, means gravitational force is weaker than Coulomb force, right? So that is first characteristic. Now second characteristic, see, whenever any particle, it is, means distance is far away up to certain limit, so then force will be saturation force. Saturation force means, we can also call it as saturation distance, means after that distance we don't have any force, right? So after this force only applicable for only certain region, for only certain distance. Now saturation force, we are having one digit, that is 0.8 fermimeter. See, if we are having distance between two particles which is far from 0.8 fermimeter, then there will be attractive force. And if we are having 0.0 fermimeter which is, means smaller than 0.8 fermimeter, then there will be repulsive force. So here far away, and here smaller than, right? So then will be repulsive force, right? So that is the second characteristic of nuclear force. Now third characteristic, this force is applicable only between proton-proton, neutron-neutron and proton-neutron. No any other particle, we don't have any other particle inside nucleus. So inside nucleus, this force is only for inside nucleus. That's why we name it as nuclear force, right? So that's our topic, guys, nuclear force. Thank you so much.